So you can see as it's starting to go faster, you can see all of the nacelles starting to point forward here.
So can you say you take off and land like a helicopter
Exactly.
and fly like a plane?
Exactly.
Kind of like that?
That's perfect. When we're hovering, we call that thrust-borne flight. And then all of the propellers articulate. So there's 6 propellers. They will all move 90 degrees. And then we fly on the wing. So we're much more efficient. We can fly faster. That means we can go further.
You call this type of aircraft?
An electric vertical takeoff and landing, so eVTOL. It's been designed to be remarkably quiet. And so we feel that it's really important to have a quiet vehicle to be able to get closer to our destinations. And here we're flying again. The noise that you hear right now is actually from the chase plane. Our plane is really quiet.
We hear just one aircraft now.
Exactly. Yeah. So you're hearing the combustion engine from the chase plane.
So that's actually quite an interesting question. You guys have any footage with sound where you can kind of like attest a little bit?
Yeah, so we flew our plane over at the same speed and altitude. And then we also flew a fixed wing plane over. We also flew a couple helicopters at the same speed and altitude. So that one was a really interesting experiment. When the plane is taking off vertically, we're about 65 dBA, which is akin to the conversation that we're having right now. When we're flying over at 500 meters, we're on like 45 dBA, and that's closer to a sound in the library. Being quiet is so important because we want to be respectful to our communities, because the last thing that we need is just another buzzing thing. It's like I've been working on this for over 10 years. It still makes me feel like a little kid, you know?
What's the range of the battery? Or
So we can fly 150 miles. And we are expecting the normal mission to be a 20 or 25 mile trip. Okay. That'll allow you to pop around congestion in cities and get places pretty quickly.
After this. Are they going to go off again?
This is a brand new industry. Traditionally, there's been the GA airplanes, like a general aviation airplane, and then you've had the big commercial planes, and then you've had helicopters. But we're kind of taking the best of all of the worlds and making this new form of transportation. As you can see, we have 6 propellers. They all can independently articulate. So when they're all pointing up, that's when we can take off vertically like a helicopter. And then when you saw it flying faster and higher, they all are pointing forward towards us. So it will actually rotate around kind of like this pin right there. And then there's a linkage here. We're actually charging, so it's plugged in. You undo all of this, and then they would articulate down. One of the really unique things about this vehicle is that it also is always an aircraft. We have a wing and we have a tail. And so on the wing, we have conventional ailerons on the side here. So if there are these control surfaces, 2 of them on the tip here, and then on the tail, we have 3 rotavators per side. And so it really is an aircraft.
You decided not to just do a big drone for humans.
By making an aircraft and an airplane first, it's a lot more of a useful platform. By having the wing and the tail and all the complexity with the tilts, it allows us to go substantially further, 3 to 4 times really on range. And then it also allows us to go multiple times faster as well.
How fast is this?
We can go up to 200 miles per hour here.
So it's not just getting out of traffic, you're also really going fast.
Exactly. I mean, this is definitely one of the first vehicles that looks like this. If we go back and think about like the early days, we spent a bunch of years iterating on different concepts before we landed on this one. Here's the subscale. This vehicle is super similar to the vehicle that you see right here, and so it has the 6 propellers and all of them articulate. We started off with something small. We very quickly realized that we were on to something. So within 2 years, we went to our first demonstrator, and this is actually a vehicle that we haven't been super public about, but it's really fun. We just built this full-scale vehicle, didn't really tell anyone. We flew closed airspace. This is where we did our first conversion and reconversion at a full scale. If you think back, this was over 5 years ago, there was still a lot of skepticism on whether how these vehicles would perform converting from the hover to flying on the wing. We had a lot of confidence with the design, which basically led us to the designs that you're seeing now. We're walking over from our flight test hangar over to where we actually build composite parts for the airframe. Pretty strong presence at the airport.
Yeah. You didn't start here though, right?
No, so our headquarters is up in Santa Cruz, California. So our founder, Jobin, he has basically made it his life's mission to bring electric flight to society, right? And actually, I believe it was in the 90s, he was getting excited about electric propulsion and flight, did some calculations and realized that really the technology was going to need another 20 years to mature. So he went off and was very successful in several other business ventures, came back to it and founded the company in 2009 with the mission of doing exactly what we're doing.
Because things were ready, more.
The pieces of the puzzle were starting to come to fruition. So this is an airlock. We're just going to stand here because we're doing manufacturing. And then we can come on in. So we do that because this is a controlled zone and we don't want drafts coming in and out. This is where we manufacture our production level composite parts. Because we have a battery electric airplane, it's really important that the airframe is super lightweight. And how we do that is with carbon composites. Find some, maybe. Do you have any carbon, like a little piece that I can show them here? Appreciate it. Okay, so this is like a fiberglass. You see it's very movable and obviously not very strong yet. So this is because it hasn't been cured yet. And so as we build our vehicles, we laminate basically ply by ply by ply to build thickness, and afterwards it'll be hard. So here, our technicians are putting the plies exactly in their location. And as you can see up, we have laser projection. There's little, basically, locators on the tool. And from there, these laser projectors scan for all of the little locators. And so it knows where the tool is, and then it puts down the exact lines for where the plies need to go.
So it's like a custom-made, like a tailored mold for your aircraft,
yes.
Right?
So all of the shapes are Joby-specific shape, and everything has a purpose on the plane. This is hand lamination. Another thing that we've been investing in is our AFP machines. So this is an automatic fiber placement machine. So on the left is where all of the carbon fiber is, and then that robot will articulate to position the fiber in the exact spot it needs to be on the part.
To me, it's fascinating. It almost looks like a textile industry.
Yes.
Some of the garments, when you see the machines, they're very similar.
Well, and if you think about it, what the material looks like, it's flexible. It is a textile, basically. And so you can kind of see there's a pretty large, almost diversity of shapes, right? So, because we build so many different parts out of composites.
So in here, what's exactly?
All of these parts are composites.
You know what it looks like? It looks like this typical kit of,
But like a model plane kit, right? It feels like.
yeah. This part of carbon fiber you're working in here, it's super long. What is it this for?
That is one of the wing spars. Airplanes are all about checklists. And so we'll go through and checklist every single part. And then after they're done through all the lamination, here's an example over here of a vacuum bag. And so basically what this helps us do is make sure there aren't air bubbles or voids within the part. From here, we will bring it over to the autoclave. So in the other room was our clean room where we actually were doing all the lamination, basically building up the thickness of our parts. This is where we actually cure the parts. And so this is when basically the end product is hard, right? So here is our 40-foot autoclave. This whole door closes, the strawberry drops, then the door closes. In it, you can see one of our wing skins. And so we'll go through a cure cycle here. And afterwards, we pull it out and you have your composite wing skin.
How much of this would have been possible 20 years ago?
A lot of this technology was still possible, but I would say it's become more accessible. So it's become easier, especially over the last 10 years, for companies to have access to some of these bigger tools that historically were pretty hard to get.
Because now, I mean, it used to just be sort of the big airline, the big airline manufacturers, right? Like there weren't many and it was a monopoly and you...
Because you are not making CAD designs and then going somewhere else and tell them produce that for us and then you receive the parts and you assemble them. You are actually trying to come up with a design yourselves. You are producing, controlling, tweaking, and having the help of people who do like big productions to kind of like put it in a streamline.
You nailed it. And the reason why we think that this vertical integration is so important is because this is a brand new industry. And being able to have a really fast loop and have the engineers that designed it, sometimes being just right upstairs or on the shop floor. And when you have a manufacturing question, you walk up to the engineer and you say, hey, what were you trying to do here? Can we modify this drawing? Can we do this? Can we update this part? This is a very old propeller, but for years we've been working on refining our propellers and understanding how to make the quietest propeller possible. The team built a bunch of different propellers with different thicknesses and chord widths, etc. And as you can see, these are also really light. I feel like you need to hold this.
One hand? No.
Oh,
wow, actually, yeah.
Yeah.
Hold one hand.
Yeah, exactly.
It's light.
Yeah, it's really light. This is why we do everything, or so many things ourselves.
And you were saying that your founder thought that in the 90s it wasn't possible to do this. What's
It just
changed?
really the battery, the specific energy on batteries was too low back then to make a system that really worked. On top of that, a lot of other technologies have improved, some of those being the compute power that it takes to run all of the controls, thought processing, etc. Also, the simulation tools that the engineers use on the ground, all of that has gotten remarkably better in the last 30 years. So now we're gonna walk up to one of our flight simulators.
Okay.
One of the things that we've done, I believe, a remarkable job on is making the vehicle really easy to fly.
All right. So I've never flown a plane.
I think that's the point.
Oh, is that the point? Okay. All right. What are we looking at?
So here we're looking at our flight displays. We have our control methods here. These are our inceptors. We might want to call it a joystick, but inceptor sounds a little bit more commanding. If you pull back on your right,
Okay.
you'll lift off.
Okay. It feels like it's turning, no?
It is turning, but as you can see, it's managing it just fine. You can see that you're still pulling back here.
I am pulling back. Should I
So
stop pulling back? We're
stop
too
pulling
high?
back.
Okay.
But if you, I mean,
Is the idea not to go too high? I mean, is there a limit on how high you can go?
the ideal flight profile is like if you were to hover this high up, that would drain the batteries incredibly quick. So the ideal flight profile would be to take off, hover, and then start moving forward as quick and put you on.
So
the
I
wing
went
as
way
quick
too
as
high.
Yeah, I mean, but we can recover. Just
Okay.
start giving it forward motion.
Okay.
And also disable TRC, which stands for Translational Rate Command. And that's kind of like an easy hover mode. Once we disable, we can see that we're going to start moving forward.
So right now it's more helicopter. Oh no, are these
No, we're
coming down?
transitioning, yeah.
Oh, we're transitioning right now.
Yeah.
It's nice you don't have to think about it. So
Yeah.
that's just how it's going to be. You don't really have to think about it. This is easy.
Yeah, absolutely. It's
Okay.
incredibly easy.
Yeah.
If you completely let go, like
Okay.
all the commands, it would
Okay.
it would fly itself. You can. So
Are we
there's-
going down?
We are, and you can tell we're decreasing at 190 feet per minute. So if you were to pull back here, you would see that that would increase. Like you're not going to get yourself into a dangerous situation. Like if you were to give a full motion to the left, seems a little scary, but
Right.
that's the max bank angle.
And that's fine.
Yeah.
But now we have wings, right?
Yeah, we are definitely on the wing.
Okay, so far really easy.
Yeah, just incredibly easy. I'm not a pilot. I've
Oh, okay.
worked in the aviation industry for roughly 5 years, but I'm a coder, so I'm an
Sweet.
avid gamer. So
Right.
as a video game pilot, this is incredibly easy to pick
Honestly,
up.
I don't think I've...
Warning, terrain.
Okay, so go ahead
Okay,
and
so I need to pull back.
level up.
I'm lower. So I was going down at the same time.
Still going down.
Still
so,
going down. Pull up.
Yeah.
Warning, terrain.
And it's warning you, but it wouldn't automatically do something.
It wouldn't take over.
It won't take over. Okay. So it looks like the
The props are moving because we're right at an airspeed where,
Okay.
like, if you were in a normal aircraft,
Okay.
we would have stalled.
Okay.
So
How do you land it?
So right now we're moving down. It's very steep. So go ahead and
Pull
pull
back
back
a little
just
bit.
a little
Okay.
bit. This is a good flight path angle to bring it in for a very smooth, like,
And then I'm looking for the landing strip.
Which is
oh, it's
gonna
way
be-
back there.
so if you
Oops.
pulled
Oh,
back
okay.
just a little bit,
Pull back. Okay. Yeah. A little low.
you might overshoot just a little bit, but don't worry too much about it. It'll probably come just,
Because will it do anything for me, or no? I really need to land.
um,
I'm not doing.
keep-
very
keep
well.
it level.
Hit the building.
don't try to hit the ground
Oh, don't?
immediately.
Okay.
Try to come to a resting hover.
I forgot now. Oh gosh, I'm gone.
Pull back on your left.
Okay. Oh, that's right. So wait.
The TRC is also actively slowing you down.
Okay.
And then you can see as we've kind of hit 0 knots, that's when you're going to bring it down.
And it's okay. Just kind of.
It was bringing down on itself right there, right?
Okay. Yeah, I didn't do much. Did we just bounce?
Just a little bit.
Thank goodness this is a simulator, because I don't think that would have been so smooth. Nobody's gotten in a plane yet.
We've done some kind of initial hovering and taxi work, but we're looking forward to doing more inhabited flight in the future. We can basically do almost all of the flight testing that we need to do remotely. This was actually our office back in the day. It was this beautiful redwood barn. We were doing everything. We were building subscales, we were building planes, we were trying things out. And you know, this is an example of an early electric motor. One of the things that's really incredible about these motors is that it just has one rotating system. There's no gearbox, there's no complexity to it. This is a very efficient motor. And what's really amazing about electric propulsion is that you can put this motor anywhere, right? So we were really having these discussions, 10 years ago, where do you put a motor here? Do you put a motor here? Do you put a motor here? You can take these motors and all you have to do is connect the wires. Or if you think about traditional technologies, you had to run a gearbox and a transmission to wherever you wanted to have a rotating propeller. It's this freedom to build vehicles that people have only kind of dreamed of or seen in movies. In 2012, we got a contract with NASA. It was distributed propulsion. And so the wind tunnels were really expensive. And the important thing about wind tunnels is that you have flow going over a wing. Basically, this is like an inside-out wind tunnel because the truck gives you the airflow.
And that says that you're now allowed to operate a commercial air taxi service.
Yes.
That's a thing.
Yes.
So this is a prototype of what a Joby passenger terminal experience might look like. So the idea is that the passengers would come in through here from the street, check in right over here, sit down and wait for their airplane to arrive.
Okay.
And when your airplane is ready, you exit out through there, board the aircraft right over there. And when one arrives, passengers will disembark, walk up and through here, and either just go straight out and into their lives or come in through here if they need to.
It's just small.
This is intended for probably 2 aircraft at the most.
Okay.
This is modular and it's transportable, so we could set it up temporarily for, as a airport terminal. We can make it larger, bigger. We can design it to the specifications we need for whatever site it is.
But unlike, I guess, a car sharing service, you do need a port. You need a place to
Yes.
that sort of.
Yeah.
You can't just call up on your phone and say, "Come pick me up at
my
this."
front
Yeah.
Down the road, maybe.
If you look at this timeline, even though we're already talking in years, we've really been able to develop a very complex vehicle in a very short time.